Hi everyone. Today we will solve 10 Codewars kata of varying difficulty, from 8Q to 6Q. The first task was that, given an array, ARR, as an argument, we had to complete the countSmileys function, which should return the total number of smiling faces. Each smiley face must contain the correct pair of eyes. A smiley face can have a nose, but it is not required. Every smiling face must have a smiling mouth. Additional characters are not allowed except for those mentioned. The function uses a loop to iterate through each string in the array. Inside the loop, strcmp is used to compare the current string, array, I, with various smiley patterns. If a match is found, the count variable is increment. The def.h header provides definitions for size_t and null. The string.h header includes functions for string manipulation, such as strcmp. If the input array is null, the function returns 0. This is a safety check to handle the case where the array is not properly initialized. The following problem contains an array with some numbers. All the numbers are equal except one. I will try to find it using the findunic function. It takes two parameters, nums, a pointer to an array of float numbers, and n, indicating the number of elements in the array. It returns a float value. The outer loop iterates through each element of the array. For each element, the inner loop compares it with other elements in the array. If an element is found that is equal to the current one, and these two elements are not at the same position, index, the unique variable is set to 0, indicating that the element is not unique, and the inner loop is broken, break. If unique remains equal to 1, it means that the current element is unique, and the function returns its value, return nums, I. If no unique element is found, if the entire array consists of identical numbers, the function returns the result of dividing 0.0 by 0.0, resulting in a representation of undefined, nan, not a number, in the floating point standard. The next task is to write a function that takes a string parameter and reverses each word in the string. All spaces in the string must be preserved. First, I allocate memory for the result string. Strlen, text, +1 is used to make sure that there is enough space for the reversed string, including the null terminator. Then I check if the memory allocation was successful. If not, null is returned. I initialize a loop to iterate over each character in the input string. If the character is a space, it is directly copied to the result string. If the character is not a space, it means it is the start of a word. The function then finds the end of the word and reverses the characters in that word. And add a null terminator at the end of the result string. Trolls are attacking my comment section. The usual way to deal with this situation is to remove all vowels from the troll's comments, neutralizing the threat. My task is to write a function that takes a string as input and returns a new string with the vowels removed. For example, the string "this website is for losers LOL" will be transformed into THSWBSTSFRLSRSLL. Note that in this catalog, Y is not considered a vowel. I initialize the loop to search for each character in the input string. I check if the current character is a vowel. If it is not a vowel, it is added to the result string and the index j is increment. A null terminator is appended to the end of the result string. This function successfully disembowels the input string and returns a dynamically allocated buffer. Given two positive integers n and p, find the positive integer k, if it exists, such that the sum of the digits of n raised to a consecutive power starting from p is k*n. In other words, writing the consecutive digits of n as a, b, c, d, is there an integer k such that the sum of a to the power of p, b to the power of p plus 1, c to the power of p plus 2, d to the power of p plus 3, and so on is equal to the product of n and k. If so, we return k, if not, we return -1. N and p will always be strictly positive integers. I declare a character array number to store a string representation of the number n. The size of the array is 20, assuming it is large enough to hold a new string. I use sprint to convert the integer n to a string, which is stored in array number. I initialize a loop to iterate over each digit in the string representation of the number. I convert the character digit to an integer and calculate its degree using the formula digit caret, p plus length. I add this value to the current sum k. I increment the length variable to keep track of the digit's position in the number. Then I check if the sum of k is divisible by n. If it is, I return the result of the division, k/n. If the sum is not divisible by n, the function returns -1. The exo function takes the string str as input and checks whether the number of occurrences of the character x is equal to the number of occurrences of the character o. I initialize two variables, counts and counto, to count the number of times the characters x and o appear in the string, respectively. Then I add a loop to iterate over each character in the input string until a null terminator is encountered. I check to see if the current character is x. If it is, I increment the counts variable. If it is o, then the variable counto is increment. Finally, I compare the number of characters x and o. If they are equal, the function returns true. Otherwise, it returns false. My next task is to take an array and find the index n, where the sum of the numbers to the left of n is equal to the sum of the numbers to the right of n. If there is no index that allows me to do this, I will print -1. For example, suppose I am given an array a1, 2, 3, 4, 3, 2, 1. My function will return the index 3, because at the third position of the array, the sum of the left part of the index, 1, 2, 3, and the sum of the right part of the index, 3, 2, 1, is 6. If I get an array with multiple answers, I return the lowest correct index. The first step is initialization. Total_sum is used to store the sum of all elements in the array. Left_sum will be used to keep track of the sum of the elements to the left of the current index. The second step is to calculate the total sum. The first loop goes through the array, adding each element to total_sum. This loop calculates the total sum of all the elements in the array. Third step, finding the even index. The second loop goes through the array again. At each iteration, it subtracts the current element from total_sum, effectively excluding the current element from the right side of the sum. Then it checks whether left_sum, the sum of the elements on the left side, equals total_sum, the sum of the elements on the right side. If the sums are equal, it means that the current index is the desired even index, and the function returns this index. Otherwise, it updates left_sum by adding the current element. If no pairwise index is found during the iteration, the function returns -1, which means that such an index does not exist. My next task is to find the first element of the array that is not consecutive. By odd, we mean that it is not exactly one greater than the previous element in the array. For example, if we have an array 1, 2, 3, 4, 6, 7, 8, then 1, then 2, then 3, then 4 are consecutive, but 6 is not, so this is the first nonsequential number. If an inconsistent number is found, I return true and set the past pointer to the number found. If the entire array is consecutive, I return false. The array loop starts with the second element of the array, I equals 1, and goes through the array, checking if the current element is not equal to the previous element plus 1. This condition detects non-consecutive numbers. If an inconsistent number is found, it sets the value pointed to by the first pointer to the current inconsistent element, arr_i, and returns true. If the loop ends without finding any inconsistent numbers, false is returned. The following solver function takes a string in the camelCase register and converts it to a string with spaces, where each word starts with a capital letter. Here is a step-by-step explanation of the code. First, we allocate memory for the result string. The formula 2*len plus 1 is used to account for the possibility that each character in the input string must be separated by a space, as well as an extra character for the null terminator. The loop is then initialized to go through each character in the camelCase string. It checks to see if the current character is a capital letter. If it is, it adds a space to the result string before the capitalization. Directly appends the current character to the result string and a null terminator character to the end of the result string. Return a dynamically allocated buffer containing the converted string. The main idea of the final kata is to count all the characters that appear in the string. If I have a string like ABA, the result should be a, 2, b, 1. If the string is empty, the result should be an empty object literals. The for loop initializes each element of the counts array to 0. This step ensures that the array is in a clean state before counting begins. The while loop loops through the input string, which is performed until the null terminator, \0, is encountered. For each character that occurs in the string, the corresponding count in the counts array is increment. The asterisk string expression represents the character at the current position pointed to by the string. It is used as an index to access the corresponding element in the counts array. After that, the counter of this character is increment. As a result, after calling this function with a specific string, the counts array will contain the number of characters in the ASCII range, from 0 to 127. This implementation assumes the use of ASCII characters and may not work correctly for other character encodings. Thank you for watching this video. Please like, subscribe, and comment on which task you liked the most or what you didn't understand. See you in the next video?